Amish beekeepers don't have access to modern solutions, but since 1900, they've applied the same protocol every April, and their colony losses are consistently lower than their neighbors. The secret isn't a new product. It isn't new genetics. It's a timing habit shaped by observation in 1900, transmitted across generations. The biology behind that habit is being confirmed today by modern beekeeping researchers. Unlike the Maya or medieval monks, this is a living tradition on American soil still practiced today. In Lancaster County, Pennsylvania, and Holmes County, Ohio, the two densest concentrations of Amish farming communities in North America, beekeeping has operated continuously since the mid-1800s, under conditions that most contemporary beekeepers would consider impossibly constrained. No electricity, no commercial queen suppliers on speed dial, no chemical treatment schedules calibrated to laboratory mite count thresholds, no package bees arriving from California or Georgia to replace winter losses. What the Amish have instead is a management calendar, seasonal, precise, generationally transmitted, and an April habit that addresses the single most consequential biological moment in the annual beekeeping cycle. Before that moment triggers the cascade of events that cost most modern beekeepers their surplus, their colonies, and their season. To understand what the Amish April protocol actually does, and why it works, it is necessary to understand what April represents in the biological calendar of a honeybee colony in the northeastern United States. April is not simply the month when spring arrives and bees become active again. It is the month when the colony's internal demographic trajectory determines whether the summer season produces surplus or disappointment. The winter cluster that contracted to a grapefruit-sized sphere in January has been expanding since February. The queen's laying rate has been accelerating with each week of increasing day length. By early April in Pennsylvania and Ohio, a strong, overwintered colony may be covering 7 or 8 frames of brood, with forager population growing rapidly and nurse bee density reaching the peak that supports maximum brood production. This is the moment that looks like success from the outside, and it is the moment that the biology is most dangerous. Because the same demographic explosion that produces a strong April colony also produces, within 2 to 3 weeks, the exact conditions that trigger swarm preparation: brood nest congestion, queen pheromone dilution, idle nurse bee accumulation, and the architectural compression that initiates the swarm sequence. The Amish beekeeper who has watched the entrance every morning since March does not see April's strong colony as a cause for satisfaction. He sees it as a biological countdown, and he acts on it before the countdown reaches 0. The specific April habit that Amish beekeeping communities transmitted across generations is neither complicated nor expensive. It is a controlled nucleus creation, the deliberate removal of a small portion of the colony's population, brood, and a queen cell or young queen, before the colony's own swarm preparation biology makes the same split involuntarily and chaotically. The distinction between a controlled nucleus creation and a swarm event is the distinction between a management decision and a biological emergency. When a colony swarms, approximately 60% of the adult population departs with the old queen at an unplanned moment, leaving the remaining colony depleted, broodless for 3 to 4 weeks pending new queen emergence and mating, and biologically unable to produce meaningful surplus during the primary nectar flow. When the Amish beekeeper creates a nucleus in April, removing 3 to 4 frames of brood, bees, and a developing queen cell into a small nuke box, the primary colony retains its queen, retains the majority of its population, and retains its foraging capacity. The population pressure that was building towards swarm initiation is relieved. The colony's behavioral economy, which was reorganizing around reproductive preparation, returns to storage and production. And the nucleus colony that was created becomes, managed correctly, a productive unit in its own right by summer, or a source of locally adapted queens for future splits. The controlled nucleus costs the primary colony nothing it would not have lost to a swarm. It costs the beekeeper a nuke box and the management habit of acting before the biological decision is made. The timing of the Amish April nucleus creation is what separates it from the same technique applied by modern beekeepers with inferior results. And the timing is governed entirely by biological signals rather than calendar dates. The standard modern advice for swarm prevention splits says, look for queen cells, then split. The Amish tradition says, split before queen cells appear. This is not a trivial distinction. By the time sealed queen cells are visible in a hive, the colony has already committed to the swarm sequence at the pheromonal and demographic level. The workers have already begun reducing the queen's food provisioning to prepare her for flight. The foraging population has already begun idling at the entrance as recruitment signals are disrupted by congestion. The behavioral reorganization from storage mode to swarm mode is already underway. A split performed at this stage can prevent the swarm from physically departing, but it cannot reverse the 3 to 4 weeks of demographic disruption and production loss that the swarm preparation biology has already initiated. The Amish beekeeper who reads his hive entrance every morning from late March onward is not looking for queen cells. He is looking for the earlier signals: the subtle increase in mid-morning forager idling, the slight reduction in pollen intake relative to the previous week's pace, the change in colony sound that experienced beekeepers learn to read before they can articulate what they are hearing. These signals precede queen cell construction by 10 to 14 days. Acting within that window produces a fundamentally different biological outcome than acting after it has closed. The locally adapted genetics that the Amish system preserves through division-based propagation, rather than purchasing replacement queens from distant commercial producers, is the second biological variable that the Amish April protocol protects in ways that most contemporary spring management advice ignores completely. In Holmes County, Ohio, where Amish beekeeping has operated continuously for over 150 years in the same forage landscape with the same seasonal patterns, the colonies that have survived decade after decade without commercial genetic replacement carry a documented adaptation to local conditions. They winter in the thermal conditions of central Ohio. They emerge in the forage timing of central Ohio, the sequence of willows, maples, fruit blooms, dandelions, and clover that defines the Ohio spring nectar calendar. Their queen's laying rate acceleration tracks the local day length and temperature patterns that central Ohio generates in March and April. A commercially produced queen from Georgia or California, introduced to an Ohio colony in spring, carries genetics optimized for a different climate, a different forage sequence, and a different seasonal rhythm. The adaptation mismatch is not catastrophic. Commercially produced queens perform adequately, but it produces a spring buildup trajectory that is modestly misaligned with the local forage calendar. The Amish colony, whose queen is the daughter of the colony's previous queen, divided from a locally proven line in the April of the previous year, builds its spring population in precise biological synchrony with the forage landscape it evolved to exploit. The April nucleus creation that the Amish tradition practices every year is not simply swarm prevention. It is the propagation mechanism that preserves locally adapted genetics while simultaneously relieving the swarm pressure that would have otherwise lost those genetics to the uncontrolled biological process of swarming. There is a practical detail of the Amish April nucleus creation that carries a biological significance most modern beekeeping accounts of the same technique overlook. When the Amish beekeeper removes frames for the nucleus, he does not select randomly. He selects frames of predominantly capped brood, sealed pupae within days of emergence, rather than frames of eggs and open larvae. This selection is not simply practical caution against chilling brood during the transfer. It is a demographic precision that determines how quickly the nucleus colony achieves biological independence. Capped brood requires no active nurse bee feeding. The bees emerging from those sealed frames over the following 7 to 10 days immediately populate the nucleus with young adults who will serve first as nurses, then as middle-aged bees, then as foragers. A complete demographic pipeline established from the existing brood without requiring a queenless period to be maintained by a dwindling population of increasingly old bees. The nucleus colony with capped brood frames achieves its first full complement of nurse bees within the first 2 weeks without any queen having yet reached full laying rate. When the virgin queen that emerges from the queen's cell, selected from the colony's own locally adapted genetic pool, mates and begins laying, she lays into a colony that already has the nursing infrastructure to support her output from day one. The result is a nucleus that builds populations substantially faster than a nucleus assembled from open brood, or from shaken bees alone. And the primary colony that donated the capped brood frames retains its nurse bee population, its queen, and its architectural integrity. Because capped brood, unlike open larvae, requires no nurse bee attention from the donor colony after the transfer. The management philosophy that governs the Amish April protocol extends beyond the single nucleus creation act and encompasses a relationship with the colony that most contemporary American beekeeping has systematically reversed. The standard modern spring management calendar is reactive. Inspect every 7 to 10 days, look for problems, respond to what you find. The Amish management calendar is anticipatory. Observe daily from a distance, read signals that precede problems by 10 to 14 days, act at the correct biological moment before the problem manifests. This is not simply a different management style, it produces a fundamentally different relationship between the beekeeper's intervention and the colony's biological trajectory. A beekeeper who responds to sealed queen cells is always managing a colony that has already crossed the swarm threshold. A beekeeper who acts at the pre-swarm entrance signal is managing a colony that is approaching the threshold and can be redirected away from it with a fraction of the disruption and none of the demographic cost. The Amish tradition did not develop this anticipatory posture through theoretical understanding of swarm biology. It developed it through the practical consequence of being a beekeeper who could not afford to lose colonies to swarms, who had no commercial package supplier to replace winter losses and no queen breeder to repair spring failures, and for whom each colony represented an irreplaceable biological unit that had to be managed with precision or not at all. That constraint produced the discipline. The discipline produced the observation habit, and the observation habit, applied consistently every morning from late March through May, produced the April protocol that modern biology confirms is the correct response to the correct signal at the correct moment. The biological mechanism that the Amish April protocol exploits, and that modern beekeeping science has confirmed in research published across the past 3 decades, is the relationship between colony demographic composition and the swarm impulse threshold. The swarm impulse does not activate when a colony is simply large. It activates when the ratio of nurse bees to available brood reaches a specific threshold, when there are more nurse bees than the brood nest can employ productively, creating an accumulation of idle workers whose presence dilutes queen pheromone distribution and whose physiological state, young with fully developed hypopharyngeal glands and no brood to direct them toward, makes them biologically available for wax production and swarm preparation. The controlled April nucleus removes a portion of this excess nurse bee population, along with the brood frames that would otherwise have produced additional idle nurse bees within the following week, and redirects them into a new productive unit before the idle nurse bee accumulation crosses the swarm commitment threshold. This is not simply removing bees from a crowded box. It is correcting the demographic ratio that drives the swarm biology at the specific demographic moment when correction is possible, and after which correction requires managing the consequences of swarm preparation already underway. The Amish beekeeper who performs the April nucleus has not performed a management intervention on a colony that was swarming. He has performed a demographic correction on a colony that was approaching the threshold, and returned it to the biological state in which the swarm impulse is suppressed by the correct nurse-to-brood ratio, the correct queen pheromone distribution, and the correct behavioral economy orientation towards storage and production rather than reproduction. The results of the Amish April protocol are not dramatic in the way that modern beekeeping literature tends to dramatize management outcomes. They are consistent. Year after year in the same Pennsylvania and Ohio farmstead apiaries, where the same families have kept bees since the 1870s and 1880s, the April nucleus habit produces the same outcomes. Lower swarm rates than neighboring operations, stronger forager populations at flow peak, better winter preparation from colonies that entered summer in full productive mode, rather than recovering from the demographic disruption of an April or May swarm, and a self-sustaining apiary expansion that requires no external input to maintain colony numbers. When a colony that would have swarmed in late April instead contributes a nucleus in early April, the beekeeper has not simply prevented a loss. He has doubled his productive unit count without purchasing a single package or a single queen. Over 5 years of April nucleus management, a starting apiary of 10 colonies can become 20 or 30 locally adapted productive units, all from the same original genetic stock, all calibrated to the same local forage landscape, none of them subject to the adaptation delay that follows commercial queen introduction. This is the arithmetic of the Amish Spring Protocol. Not dramatic, not commercially interesting, not requiring any product. Just the compound biological return on a management habit applied at the correct biological moment, every April, for as long as beekeeping has been practiced in Lancaster and Holmes County. The biology has not changed. The window opens every April. The signal appears every April. And the Amish beekeeper who learned from his grandfather to be at the entrance before the morning foraging begins in late March is still reading it the same way it has been read for 125 years. What the Amish April Protocol demonstrates, with 125 years of continuous practice in two of the most intensively documented traditional farming communities in the United States, is a principle that the most productive commercial beekeepers of the early 20th century also understood, and that modern beekeeping biology has since confirmed. Swarm management is not a reactive practice. It is an anticipatory one. The beekeeper who waits for sealed queen cells is responding to a biological event that has already committed the colony's behavioral economy to a trajectory that costs the season. The beekeeper who reads the pre-swarm entrance signals and creates the April nucleus before those queen cells are initiated is redirecting the colony's biological potential into a productive unit rather than allowing it to self-organize into a swarm event. This is not a complicated principle. It is not an expensive one. It requires no product, no treatment, no commercial queen, no package bees. It requires the discipline to be at the hive entrance in the morning from late March onward, the knowledge of what pre-swarm forager idling looks like when it appears, and the habit of acting on that signal with a controlled nucleus before the signal progresses to something less correctable. The Amish beekeepers of Lancaster County and Holmes County don't talk about this the way a beekeeping video does. They simply do it every April because their grandfathers did it, and their grandfathers' grandfathers did it, and every generation that did it consistently produced fewer swarms, more productive colonies, and a self-sustaining apiary that grew from locally adapted stock without the recurring cost of external inputs. The biology is the same in your apiary. The signal appears the same way. The April window opens and closes on the same biological schedule. The only variable is whether the beekeeper is positioned to read it. If this kind of historically grounded biology-first precision changes how you approach your April mornings at the hive, subscribe. There is more forgotten management knowledge ahead. The kind that worked not because it was sophisticated, but because it was correct.